future, your distances would be D1 and D2. Your fixed points are going to be your foci. And so then if I were to take D1 plus D2 from any point on my ellipse, I have to get the same number for a specific ellipse. Now that number is going to change depending on the ellipse that you have, but it will always be the same for the same ellipse. Okay? Your center is going to be kind of like your center of your circle. Okay, it's going to be in the middle. We have vertices, which are along your major axis, which is going to be your longer one. Your minor axis is going to be the shorter one. We have two axes this time. So how many axes does our parabola have? One. Why does our ellipse have two?
Because there's two different radii.
Because there's two different what?
Radii.
Not quite. Okay, so specifically, what do you mean by in half? Okay,
Symmetrical.
there we go. Yeah, so technically I could split it through the center a whole bunch of ways, right? But it's specifically going to be symmetric two different ways. So this time we could fold it like hot dog ways or hamburger ways, and we would still get a symmetric shape, which is why we have two this time. So we have two vertices. They are not labeled, but we also have two co-vertices. So your vertices are going to be at the end of the major axis, and your co-vertices are going to be at the ends of your minor axis. Now for this one, it has your major axis going.
Bennett,
Yes.
may I please get Lane Watt for checkout, please?
Sure. So for this one, your major axis is going horizontal, okay? But you could also have it turn to where your major axis is going vertical, and then basically everything is just rotated 90 degrees. So let's look at some equations. So we have two standard forms. They're basically the same. The only difference is our location of our a squared and our b squared. And the reason that they are switched is because our a always has to be bigger than our b. So if it's longer going horizontal, your a will be with your x. If it's longer going up and down, your a will be with your y. And our center is going to be located at h comma k. And it always has to equal 1 in standard form. So let's label some things. So we have two vertices, just like we had before. And remember that they are along our major axis. Our center is in the middle. And the important thing about our major axis that they tell us is that the major axis is going to be 2a. So that means that the distance from your center to one of your vertices is just a. Likewise, we have our co-vertices, and there are two, and they are along our minor axis. And its length is going to be 2b, which means that the length to one of ours is just E. Then our last thing that we have are the foci. And that distance is going to be a value that we label as C. Are we all with me so far? A lot of labeling and variables and such. Now, an important thing to notice is that we can create a triangle. Do y'all see that? From my co-vertex to my focus. Yes? What type of triangle would that be? Right triangle. So then notice that, okay, this length is C, right, my base. My height would be what? B, right, because it has to be symmetric. And then we would have to do a little bit of some math work, which you can look up if it really is going to bother me or bother you. Or you can just kind of trust me that this value is going to be A. Does that make sense? And the reason that we want that is because from there we can create this relationship or equation for us that tells us that C squared equals A squared minus B squared. Or in other words, notice I would have C squared plus B squared equals A squared because A squared is our hypotenuse. But we want our C squared to be what solved for. It is the Pythagorean theorem. Yeah, we've just labeled our A's, B's, and C's a little bit differently. Yeah, but I mean, you could solve, just like if you're a normal Pythagorean theorem, you could solve for any variable that you want. Same thing here. And that's going to be important because depending on what information you're given, sometimes you might have to find the other information using that equation. Yes?
So does the focus fit the A as well?
No,
No.
not necessarily. Very rarely will it do that. Now, depending on, so like, where your focus is located on this line is going to depend on how like stretched or like circular it is. The closer that your focus is to the center, the more of a circular like shape you're going to get. The closer that your focus is to your vertices, the more of like an elongated ellipse you're going to be. I just drew them in the middle this time, but no, they're not halfway. Good question. Other questions?
I just want to make sure this is not really on the scale. So the A, the major axis, is the same distance as the A for that triangle, correct?
Correct.
Okay.
Yes. And like I said, it takes a little bit of algebra work to like get to that, but that's where we get that C squared equals A squared minus B
Yeah.
squared. But I mean, like, you don't really need to know that that's A because we don't ever actually use that right triangle. We just use that formula.
Okay.
I just wanted you to know, like, oh, I'm not just pulling that out of thin air. Like, we can actually get that from our drawing. So, let's look at an example. This says, find the standard form of the equation of the ellipse having foci at 0, 1, and 4, 1, and a major axis length of 6. It says, as shown in the figure, we're going to draw ourselves our own figure. So our foci would be at 0, 1, and 4, 1. correct? So what type of ellipse are we going to have? What? Yes, why is it horizontal?
This is the major axis.
I agree. Because your foci have to be on your major axis, which would have to be horizontal in this case. Which means that our ellipse would also have to be horizontal in this case. And that's going to be important because that's going to tell us that our A is going to have to be under which of our variables? X or Y? X. Yep, because if I'm longer going across, that means that my bigger number has to be with my X. So we're looking at the equation X minus H quantity squared divided by A squared plus Y minus K quantity squared divided by B squared. Now, do we have any of those things right off the bat? Or do they give us any information that we could maybe use to find that?
We have our A.
We have our H and K. They do not give us our H and K.
We have
Yes.
our
So when it says it gives you the axis of 6, does that mean like A equals 6 or
Not
2A?
quite.
Or 2A equals 6.
Correct. So, remember the length of your major axis, in this case, is 6. But then remember that the distance to each vertex from our center is A, right? So the whole length would then be 2A, but we could work our way backwards. So what does A have to be? 3. Alright, and then if we wanted to find our center, because they don't give it to us, what would we need to find?
The next one.
Of
0, 1, and 4, 1.
Okay, what is our midpoint formula?
Change in.
No, because change would be subtraction.
Average.
There you go. So you would have 0 plus 4 divided by 2, comma 1 plus 1 divided by 2. Your distance is the change. So we would get 4 divided by 2 gives us 2. 2 divided by 2 gives us 1. So that is our midpoint, which also happens to be our center, right? Because everything is symmetric. So that means that the middle of my two foci has to be my center. So what does that give me? What are the two variables that are represented by our center? H and K. So which one's H? 2. And we said that A is 3, so it's going to go on the bottom. 9. And our K value is going to be 1. So then what do we have left to find? Our B value. Now, do they give us anything about our covertices? Or our length of our minor? No. But do they give us any other information that would maybe allow us to be able to find B?
If you use the triangle from before, you have the length of A, you can find the length of C by using your midpoint and one of the foci.
Yeah, so if I know that my center is at 2, 1, and my C value has to be the distance from my center to one of my foci, how far apart are they? 2. Are we all okay with that? If we couldn't tell that they're 2 units away, you could always use your distance formula. But it takes us 2 units to get to 0, or 2 units to get to 4. Either way. So then, like you said, we can use that formula that we had on the previous page because we know A and C, so we can plug that in to find B. So what does B squared equal? 5. Do we agree? Now, if they asked us to find like your co-vertices or the length of the minor axis, or they just asked you what B was, then we would have to take the square root, and the square root of 5 is going to be 2 point something. But in this case, we're just writing the equation. So remember that our equation has B squared in it, so we don't really need B. So we just plug in B squared. And we're done. Questions on that?
Wait, so how did you get 9 for A?
I got 9 for A squared.
A squared. Yeah.
Because A is 3,
Oh, okay.
so then I just squared.
Okay, and then you got C from the distance between
The center,
the center and
2, 1, or both.
1.
It doesn't really matter which one. They're both the same.
Mhm.
Question? Other questions? No? Alright. So let's go another one. This time we're going to graph. So they give us x plus 2 quantity squared divided by 9 plus y plus 2 quantity squared divided by 4 equals 1. So is this going to be a vertical or a horizontal ellipse?
Horizontal.
Why?
Because the greater number in the denominator is my x, which means
Agreed.
that it's the major axis.
So my bigger number is with my x, which means that it's going to have to go across. So I'll probably start by labeling a couple of things. Where is the center of our ellipse going to be? I disagree. What? Don't have different answers?
-2.
-2. Because remember that our standard form equation has a subtraction sign, which means that we always have to flip the sign of our equation. So then what is our A value?
3.
And our B value? 2. So remember that in my denominators are my A squared and my B squared, so we have to take these square roots in order to find our A and our B. From there, we have enough information that we can graph. So our center is at -2, -2. The major axis is going to be 3 in both directions. And we know it's horizontal because it's below our x. Then our minor axis is going to be 2 units in both directions. And then basically we just connect it all. And we're going to pretend that my ellipse looks nice and symmetrical. It's not going to. But close as possible. I'm also not going to grade your ellipses on your homework on symmetry, so as long as I can tell where your center is, and that your vertices and your co-vertices are in the right spot, then that'll be fine. Questions on that? Yes?
About the center part, it's the other
Like how I found those points? I just went 3 left
These
and
are horizontal. So go 3 to the right, 3 to the left, and these are you go 2 up and 2 down.
other questions? They just asked us to graph it. Now, if they asked us to find our foci, what would we have to find? So right now we have our vertices, our co-vertices, but if we needed our foci, what would we have to find?
Distance of C.
The distance of C, and how would we find that?
C squared equals A squared minus B squared.
So C would equal the square root of 5, right? So because our square root of 5 and it's going horizontal, right? That's my distance horizontal from my center. Which value, x or y, would we add and subtract our square root of 5 to? So remember that C is going to be the distance from my center. So I'm going to add or subtract it to my x value or my y value of my center.
X
It's
value.
going to be the x value. So I can write my foci as negative 2 plus the square root of 5, comma negative 2. And then negative 2 minus the square root of 5, comma negative 2. And if you wanted to graph those, you would just plug negative 2 plus the square root of 5 into your calculator. And it's going to be 0 point something, right? Comma negative 2, which is fine. Yes? No? Maybe? Questions on that? Alright. Let's look at another one. What do we have here? What did they ask us to do? Sketch the graph. Well, what's different? It's non-standard form. So thinking back to our parabolas, how do we put things in standard form?
Completing the square.
Completing the square. But how many things are squared this time?
2.
Bless you. Yeah, we have 2 things. So we're actually going to have to complete the square twice. So our first step is going to be to write the things that have the same variables by each other. And in this case, I'm going to move anything that doesn't have an x or a y to the other side. So then we're going to group our x's together and group our y's together, since we have to complete the square with both of them. Now, before we can start completing the square, what did we say we have to make sure of? What equals 1?
The equation, or just the square one.
Yeah, the squared. So whatever's in front of your squared has to be 1. So for our x, we're okay. For our y, we have a 4. So how do we get rid of the 4? We're going to factor it out. Which gives us y squared minus 2y. Now, remind me, how do I find my missing piece in order to complete the square? And the formula. B over 2 squared. So b divided by 2 quantity squared. So for our x's, my b is 6. Agreed? So 6 divided by 2 is 3. 3 squared gives us 9. For our y, our b value is negative 2. So negative 2 divided by 2 is negative 1. Negative 1 squared is 1. And then remember, we have to balance out our equation. So we would either have to subtract from the outsides of each of our parentheses, Or we could just do the same thing to the other side. So what am I going to add to the other side? Not quite. I'm going to add 9 for my first one. What do we need to add for our second one? Not 1.
2.
Not negative 1.
4.
Why 4?
Because it's multiplied by 4 on the outside.
Yeah, because we have a 4 on the outside of our parentheses, which applies to everything, including that 1. So to keep the equation balanced, we would have to add by 4. So now we can factor. And remember, the whole point of completing the square is that we want to have 2 perfect squares now. So we have negative 9 plus 9 is 0. So then we just end up with 4 on the right-hand side. So how do I know that this is not a circle that has a radius of 2? We could, but just by looking at the equation I can tell. So what about that equation is different from just having a circle?
Is it because there's a 4 on the outside of the one?
Yes. So if I had a 4 on the outside of both of those, then I would be okay, and it would be a circle. Since I only have a 4 outside of the 1, okay, it's going to be an ellipse. And what do our ellipses have to equal? 1. What is our ellipse equaling right now? 4. How do we get rid of the 4? We're going to divide everything by 4 because that's what's going to give us those fractions that give us our A and our B. So we would get x plus 3 quantity squared divided by 4 plus y minus 1 quantity squared. And what's going to be in my denominator?
1.
1, because my 4 divided by 4 equals 1. And then now we do indeed equal 1 like we were supposed to. Agreed? Alright. Then I want you to go ahead and graph it. You wrote it right down. Yeah. So we end up with a horizontal elliptical shape. Yes?
Yes.
Questions about any of that? Alright. Skip that one. Now we're going to talk about eccentricity. Have any of us heard of eccentricity before? No? Sometimes it comes up in some of your science classes when you're talking about like planetary motion. But if you haven't, so eccentricity, E, Okay, this is a different E than like the E that's like 2 point stuff. Okay, different E represents your eccentricity, and it equals your C value divided by your A value. Now, your eccentricity always has to be between 0 and 1. The closer that we get to 0, the more like a circle is going to be. The closer that our eccentricity is to 1, the more not like a circle it is. Okay? So let's take this a little bit into our science classes. We're talking about planetary motion, talking about orbits, right? So would like our inner planets have an orbit that has an eccentricity closer to 0 or closer to 1?
Closer to 0.
Agreed, because your inner planets have an orbit that's really, really close to a circle. We can't technically call it a circle, but it's really close to a circle. Now, for our outer planets, you know, like Pluto, because I still think Pluto's planet, would it have an eccentricity closer to 0 or closer to 1? Closer to 1, because it has to be like slingshot super far, which makes it really, really wide. Are we all with me? Alright, so let's look at some eccentricities. Now, the key thing that we're going to be looking for are our A and C value. But on our first example, okay, we can find our A and our B value pretty easily, okay? But then we're going to have to use that handy-dandy equation that we've been using to help us find our C value. So what is our A value for our first one? 3. Because remember, your A value has to be bigger than your B value. So in this case, it's underneath my Y. What would our B value be? 2. So then we could use our equation. And we get that C is going to be the square root of 5. So then plugging that into our formula, we have the square root of 5 divided by 3. You would plug that into your calculator. And what do we get? I know it's going to have to be 0 point something, because it has to be between 0 and 1.
0.75.
3 decimals.
745.
745?
Yep.
Okay. So not like super, elongated or stretched out, but still not very circular. Okay? Now, on our second one, what are we going to have to do first? Before we can find any of our stuff? Put it in standard form. So I have to move my negative 52 over, factor out my 9, then we would complete the square with each of our variables. And then what do we need to add to our negative 52 this time? We need to add 25, right? And then we would also have to add not 4, but 36. Yes? Sorry? You can wait until I'm finished with class. So, because I have to do 9 times 4, okay, which would give me the 36. So we would get x minus 5 quantity squared plus 9 times y plus 2 quantity squared. And what do we have over on the right hand side? 9.
Just kidding.
So then again, remember, in order to get that 1, we would have to divide by 9. Okay? So what is my A value this time? 3. And our B value? 1. So then we would have C squared equals 9 minus 1. So we get that C equals the square root of 8. So our E is going to equal the square root of 8 divided by 3, which is what?
So it's like
942.
Yeah.
So that one's really not like a circle. It's going to be really, really flat. Okay? Does that kind of make sense? So the biggest things with these are going to be able to graph them, but also to be able to complete the square. Like I said, completing the square is going to be really important because you have to be able to do it